Hi, Kim here. So before diving into how CTS works, I want to approach it from a bird's eye view. A tile of HashiCorp is simple, modular, composable. It builds off a widely known Unix philosophy, where each product at HashiCorp in its portfolio solves a bespoke problem space. And they solve it in such a way that some have risen to become industry standards. Though what's interesting about industry standards is that new patterns manifest. With new patterns, you have new problems. And so for this recent tech phase where most of it standardizes on containerization, you got service mesh, infrastructure as code, and other recent cloud buzzwords out there right now. What's common is that the networking layer becomes inevitably dynamic. Services are spinning up and down to scale. Things are deployed in different places. And you need to be on top of like your timeouts, your authentication, your permissions. It's overall increasingly difficult to keep everything up to date and connected with the actual state of your network. This is where a tool named Consul-Terraform-Sync can come in and extend the dynamic nature of today's networking and be proactive with everything that goes on with your cluster. We have early adopters of CTS who have cut down manual ticketing systems that would take like 4 to 5 minutes to like even up to a week to close out in order to update their network infrastructure down to almost instantaneous. You'll see it in seconds. This is accomplished by integrating Consul's service discovery with Terraform and its robust ecosystem. As I mentioned earlier, a tile of HashiCorp is simple, modular, composable. So you have Consul, which solves like the dynamic networking portion. And then you have Terraform, which is a declarative tool that allows for repeatable provisioning through infrastructure as code. Where CTS comes in is that it bridges the gap between the two and introduces a dynamic nature to Terraform execution with the focus around Consul networking. And now to dive into how all of this works. So you would have your normal Consul cluster with your servers and your agents that monitor your services in your cluster. And then you have CTS, which is run as a separate binary in your cluster. When CTS starts up, it will install Terraform CLI locally, or it will discover one that's existing on that system. Next, it sets up the information flow. It connects with Consul and it monitors the service catalog. CTS uses the service catalog as a source of truth for discovering network-related changes, and then it translates that into configuration to be used by Terraform. From there, CTS dynamically generates Terraform configuration files to automate the execution for a compatible Terraform module of your choice. And what's awesome about leveraging Terraform in this manner is that CTS is completely modular because it builds off of Terraform, which is modular. You can declare what infrastructure or resources that you want to update based on Consul discovered changes. And that could be something like a firewall, a load balancer, or really anything that has an API and a Terraform provider. This can be done by defining and building compatible Terraform modules that suit your organization's needs because everybody's infrastructure is quite unique. And so to summarize, you define the Terraform module and CTS automates Terraform execution for it. And this is done over time as Consul monitors your cluster and discovers any changes. Now this talk, we're going to focus on introducing the new CTS Enterprise that supports the highly anticipated integration with Terraform Cloud. This further extends the benefits of adding Terraform to your network management layer. CTS with Terraform Cloud is offered as a part of the Consul Enterprise package. It supports all tiers on Terraform Cloud and Terraform Enterprise, the on-prem offering. Now a brief overview on how CTS runs with Terraform, both the CLI or with Terraform Cloud. So on the left side, you have the Terraform driver, which CTS installs and automates a local Terraform CLI binary and manages local workspaces under different working directories. It generates Terraform configuration files that represent the root module and references your compatible Terraform module. Along with that, it also generates template files used for generating input variables. The input variables are dynamically sourced from the Consul catalog, and then those variables are re-rendered, updated on disk when services in the Consul catalog change. Now moving on to the right side with the Terraform Cloud driver, what differs here is that CTS now automates remote workspaces. on Terraform Cloud. This is done by generating a similar root module, and it references your compatible module. Then it generates those artifacts and uploads it as a configuration version for that workspace. So on the right side here, you no longer see the .template files, and instead the input variables are updated directly as secured workspace variables. So this is a non-comprehensive list of comparing the features that you would benefit from for CTS when integrating with the CLI versus the cloud. And the big takeaway is, like, overall, things are more secure when Terraform is executed in an isolated environment that Terraform Cloud offers with remote workspaces. And you can further mitigate automation risk by making the most of Sentinel to enforce governance policies. Additionally, you can even set workspaces to notify you when CTS automates a workspace run. So you're completely in the loop of all the automation that goes on. And so to do all of it, this is the small bit of configuration to set CTS to connect with Terraform Cloud. And so you have a Terraform Cloud driver block. And this is where you set the address, the organization, and authentication. For authentication, you don't have to hard code your token directly into a configuration file, but instead CTS has this nifty support where you can template out and query sensitive information from different sources, like the shell environment or the console KV, or even HashiCorp's own vault. Another required component to get all this running for CTS is a task configuration block. This pieces together all the moving components, and so you have the task name, which is used as the workspace name, and then you have the module source. The module source here points to a module on the public registry that is compatible with CTS. You could also point this to a local module or even one published on the private registry on Terraform Cloud. Services is another task configuration I'd like to call out. It's a list of services that you can specify to monitor the console catalog for changes, and this is what determines when Terraform is executed for this workspace. There are a few mechanisms that you can choose to trigger a Terraform run for a CTS task. And here's the default where any change to a service that matches the name, here would be API, would cause a run, like changing an IP address, the health status of that service changes, or a new instance is registered or one has been removed. Other triggers that can determine when tasks should be executed include like monitoring the console KV for changes or running that task on a schedule. And you can even more freely have a task monitor services that match a regular expression. This example right here matches all services that have the prefix API in the service name. That's the rundown on CTS integration with Terraform Cloud. And now I'd like to hand off the presentation to Melissa, who will show all of this in action.
Thanks, Kim. So our demo is going to be broken up into 3 main stages. I'm first going to go over what our demo application and its ecosystem looks like before running CTS, and then go over what our expectations are for after CTS is running. I'm then going to go over all the initialization steps that happens when you first start CTS. And then I'll show that when CTS is running, how it monitors console for changes and then triggers Terraform Cloud runs based on those changes. I'm also going to be adding a notification to one of our Terraform Cloud workspaces to showcase that feature as well. So our demo application consists of a web application that calls an API via a load balancer. The API returns the name of the node, and the web application consumes that name and displays it in a message, "Hi, I'm node name." Each of the web nodes and each of the API nodes has a console agent running on it, and that console agent is in constant communication with the console server. But to start off, I'm going to have only one web node and one API node. And let's say when you create a new API node and you register it with console, we want that API node to be put behind our load balancer. And let's say when we create a new web node and register it with console, we want that web node to be granted network access to our load balancer. We can accomplish all of this with Consul-Terraform-Sync. So let's take a look at our console setup first. You can see we have 2 services, our API service and our web service, and each of these services has a single instance associated with it. And you can see those individual instances here with their given node names. In this demo, I'm going to be using AWS EC2 instances. And so the nodes are registered, but since CTS hasn't run yet. If we go to our web application, it can't connect to our load balancer. And even if it could connect to our load balancer, that load balancer doesn't have any API nodes behind it, so it's returning a 503 service unavailable. So let's see how we can have CTS bring our application to a working state. So this is our CTS configuration file. You can see we have console configured here with the address. You can also configure authentication and TLS in this part of the configuration as well. We have the Terraform Cloud driver that Kim showed previously, which gives all the information needed to connect to Terraform Cloud, so hostname, organization, and token. Also, because our tasks only use the AWS provider, the only required provider here is AWS. So then we have our Terraform provider block. In this case, it's an AWS provider, so we have to provide things like region and the credentials, access key, secret key, etc., in order for our modules to be able to connect to AWS to update our resources. We then have our tasks configured. The first one is our load balancer task. This one monitors our API service and puts those API nodes behind the load balancer when it runs. It's configured with a CTS-compatible source module, and that module uses an AWS provider. And the module also expects an input variable which indicates which AWS resource needs updating. And we pass that variable via a variables file. So then we have our next task, which is our security group demo task. This task is the one that updates our network rules to allow access to the load balancer from the web nodes. So it monitors the web service. It has its own separate but also CTS-compatible Terraform module as the source. Also uses AWS as the provider, and also expects an input variable. In this case, it would be the security group we're updating. Again, passed through a variables file. And you can see the example here with a security group ID as the key, and then we provide the value with the ID. So that's all that's needed to configure CTS. Let's start CTS. So here I have a Docker container where I've already put my configuration file plus those two variable files. So I'm going to start the CTS binary with Consul-Terraform-Sync. I'm going to provide the configuration file. And I'm also going to be running it in its default mode, which is daemon mode. So it will be running continuously even after initialization. So starting CTS, you can see it creates two workspaces in parallel, one for each of the tasks, with the workspace name reflecting the task name. And this parallel initialization is a Terraform Cloud driver feature. In the Terraform CLI driver, because it uses the local Terraform executable, it outputs those Terraform logs to your local console. And if you had, say, one of multiple tasks that was causing a startup failure, it would be difficult to debug if all those logs were outputting on each other. But we don't have that problem in Terraform Cloud because each task has its own workspace, and each workspace has its own logging. And so I also had CTS create our workspaces here, but you can use existing workspaces if you want. They just have to follow a few restrictions. Namely, they need to be in remote execution mode. They need to have no version control system attached to them already, and they can't have any configuration versions created. And these are really guardrails we've put in place so that you don't accidentally override a workspace that's being used for a non-CTS purpose. And so now that initialization is done, let's take a look at what's happened. And we'll first look at our security group demo task. So this is a workspace that was, you can see, is created by CTS. CTS also queued a run and also created some variables in this workspace. So the first variable you see here is the security group ID, which is what I had shown previously in our variables file. There's an AWS variable, and this has all those AWS provider attributes, the region, the credentials, etc. And then there's the services variable. And the services variable is how CTS provides your module with the most up-to-date information from Consul. So if you recall, this task monitored the web service, so you only see here the web node and not the API node or that console server node. And you're not limited to just one service, so if you had multiple services, you would see all the nodes for all the services in this variable. And so now let's take a look at the run that CTS queued, which uses these variables. So you can see it was queued here. If we go to it, you can see there are 3 stages of our Terraform Cloud run. These are the default stages. There are additional ones available, but again, for this demo, we just used plan, cost estimation, and apply. So first, in the plan stage, this is where Terraform plan runs, so you get a preview of what will be changing in your infrastructure. In this case, it'll be a security group added. Then you can see in the apply, this is where the creation actually happens, and it's returning the ID of the security group rule that was created. And so a similar one was done for our other task, which is the load balancer task, except for this run, it will update the load balancers and it will monitor the API service. But again, it has the 3 default stages to it. And so now let's take a look at our application. If we go back to our load balancer and refresh, we can see now the API is responding through the load balancer. And if we go to our web application, we can see it is able to access the API through that load balancer. So at this point, CTS is fully initialized and running in daemon mode. But let's see how CTS keeps our network infrastructure continuously up to date by monitoring Consul. And we'll do so by adding a new API node to our API service. And so for this demo, I already have another instance up and running. It just needs to join the API service by starting the Consul agent, which I'm doing manually with this command. So you can see it's synced with the API service. CTS has detected the change, and it will trigger a run in Terraform Cloud for our load balancer demo task, and only our load balancer demo task, since that's the task that is monitoring API services. The run that is queued is very similar to the initialization run, so it'll have those same 3 stages. The difference here is that it's now aware there are 2 nodes associated with the API service, and it knows the first one has already been put behind the load balancer, so all it needs to do in this apply stage is add that second node to the load balancer. And so now that this is complete, let's hop back to our application. So I first want to show you the Consul UI again, just to show you that you can see that there are 2 instances associated with the API service now, and their given node names are here. And again, if you want to look at the individual nodes, that's also available, and you can see there is a new node. And so if we go to our application and refresh, you can see now we are able to get responses from both the nodes behind the load balancer. And so now for the final part of the demo, I'm going to be adding a notification to one of our Terraform Cloud workspaces so that you can see how you can be automatically alerted whenever CTS kicks off a run in Terraform Cloud. And since we already did a change to the API service, let's do a change to our web service by adding, again, a new node. So you can see this new web node is unable to connect to the load balancer, even though the load balancer is still up and running. So let's go to our workspace. I'm going to first add that notification, and then I'm going to be adding that node to the web service. So go under Settings, Notifications, Create a Notification. We're going to be doing a Slack notification in this demo. The name, I can just give it the name of the task. I'm going to give it a Slack webhook URL, which is pre-configured in Slack. And then you can select what you want to trigger this notification on. In my case, I just want to see when the task is finished. So either it's completed or it's errored. So when you hit Create Notification, you can see that there's just kind of a test notification done to confirm the integration between Terraform Cloud and Slack. And so now let's go and add that web node to the web service so we can trigger a run and trigger that notification. So again, already have the instance up, just needs to run Consul agent. You can see it's synced to the web service, and CTS has detected that change to the web service, and then kicked off a new run in the security group demo task. And so yeah, this run will look the same as I've already shown. So I actually want to jump back over to the variables and take a look at that services variable again. So in this services variable, if you recall before, it only had one node, but now that there are two web nodes, it's showing both of the nodes here in this variable. And again, this is how your Terraform module has that most up-to-date information from Consul. And so now this apply is finished. You can see the notification was triggered. And in that notification, you can see just some basic information about the run, like a link to the URL and the fact that it ran an apply and that it passed. And so now to close the loop on our demo, let's go to our application one last time. And if you refresh, you can see now that web node does have access to the load balancer. And so that's it for the demo. I'm going to hand it back to Kim to close things off.
Thanks, Melissa, for the in-depth demo of the Terraform Cloud integration. To learn more about Consul-Terraform-Sync, you can drop by the console.io website or learn.hashicorp.com and find the project under Network Infrastructure Automation. You can hit us up on the open source repository on GitHub at HashiCorp/Consul-Terraform-Sync. And that brings us to the end. Thanks everyone for following along. I hope you enjoy the rest of HashiConf 2021.